Hi everyone, I'm going to be running through the TUT questions for week 4 today. Thank you for joining me. You can come have a look and see how I work through these questions if your tutor has had issues with projectors or showing you how to do this, because this is an Excel based TUT this week, so I'm going to jump straight into it. Question 1, the results for the first test for a group of 25 STA1000S students in 2016 is shown below. Also given as a percentage out of 100 and are ordered from smallest to largest. Okay, so they've done some work for us already by actually ordering the results, and they've actually given us the total number, so we know total number is 25. So we're going to jump straight into A. Compute the 5-number summary using the formula in Introstat. So if you haven't done that already, get out your Introstat, have a look and see all the numbers for all the formulas for the 5-number summary, and then we can jump straight into it. So I've got them up already. You've got your min, you've got your lower quartile, you've got your median, you've got your upper quartile, and you've got your maximum. And so we're going to want to figure out the ranks and then the actual values. I've got the formulas here right next door. So the first two, very easy, min and max. Jump straight into the table, we can see the minimum, 31, maximum, 94. It's been given to us that they are already ordered from smallest to largest, so we don't have to order them again. So we can put in minimum, it's going to be rank 1, and the actual value is 34, and the maximum will be rank 25, because there are 25 numbers. Let me just double check. Okay, so that will be 94. Okay, awesome. Now, jumping into the next thing that we need to calculate. Not the lower or upper, but the median. We've got our formula over here. It'll be n plus 1, all in brackets, divided by 2. So we know we have 25 numbers. We're going to add 1. That gives us 26. And then we go divide that by 2. That'll give us 13. So we know our median will be of rank 13. Cool. So now we just need to look up where number 13 is. We can count. So you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we know our median number is going to be 76. The middle, right in the number. Put that down, 76. We then jump to calculate the low before we do the upper. We see our formula is m, or the median, in square brackets. This means that if the rank we calculated over here contains a decimal, as you'll sometimes find that it might be 13.5 or 14.5 or 12.5, you just drop the 0.5. So say this were 13.5, we drop that 0.5 and we just use 13. But thankfully we don't actually have any decimals, so we can ignore that. And so we take 13 plus 1 divided by 2. We can pop that in. Okay, so we've got that up. Plus 1 is 14 divided by 2 gives us 7. Okay, so we know we'll be looking for rank 7. Go back into our table. We can count 1, 2, 3, 4, 5, 6, 7. Okay, so we know the value of rank 7 is 52. So we can pop that in. 52. Okay. Cool. Now to deal with the upper, we take the total number, we subtract the lower quartile rank, and we add 1. Very simple, no divisions this time, so we're going to be taking, one second, there we go, we're going to be taking 25, we subtract our lower, which is 7, we add 1, and that gives us 19, so we're going to have to look up the value at rank 19. So let's have a quick look. Okay, you've got 5, 10, 15, 16, 17, 18, 19. So we know at rank 19 the value will be 83. Okay, so we can pop that in. Okay, and there you go. There's our 5-number summary. We've got the minimum, we've got the maximum, low quartile, median number, and the upper quartile. Very good. Okay. So we jump back to the questions. A, done. Cool. And of course you didn't actually have to do this using Excel. I just did it so I could show you. You can also do this on paper. using Excel isn't necessary, so this would have been fine. The reason they said not to use Excel is because Excel actually has a formula that will calculate the 5-number summary for you, and that then just, you know, what kind of, yeah, you don't have to do any work then. So, but we would like you to do some work and see how it actually works. Cool. So we're going to go now to the next one. Identify any outliers or strays. Now, if you don't know what an outlier or a stray is, go watch the videos, go do the readings, have a look and see what is meant by these. Strays and outliers, we're essentially just looking at boundaries for where we might want to see if values lie or greater than them. So if we have extreme values, if we have a couple of extreme values, using strays and outliers, or finding the strays and outliers, will help identify those extreme values. And so the formulas we have are almost identical, except for with strays we only use a multiple of 3, and for outliers we use a multiple of 6. M being medium, upper being the upper quartile, low L being the lower quartile. And again, we'll be dealing with, this time we won't be dealing with rank, we're going to be dealing with actual value. So 5-number summary, look at rank, pop in the actual value. Calculating strays and outliers, we also want to look at the actual value. We're not looking at rank 13 plus 3 minus rank 19 minus 13. We're actually looking at the actual values that we have. So we jump straight in, calculating the upper bound for the strays. We're going to be going, okay, so we've got the median, which is 1376. Okay, so 76 plus, open bracket, 3 times, I'm going to make another bracket there. We've got the upper value being 83, minus the median 76. Whoops, I made a bit of an error there. Okay, let's start again. Oh, there we go. Okay, so we've got 83. Okay, fine. Minus the median number, which is 76. Okay, I'm going to close that one off and then close that one off, and that gives us 96. So we know the upper bound actual value is 97. Sorry, 97, not 96. Awesome. Okay. We now do the exact same, but for the lower bound of the strays. We also say we're finding the fences. So these values that we're going to find here and here, they are considered fences. Okay, so we again start with the median number, 76. Okay, 76 minus, open bracket, 3 times, open bracket, the median, this time 76, subtracted by the lower value being 52. It's fine. Close those, equal to 4. Very happy. So we know these are our 2 fences when we want to calculate or find any strays. So if we have any values that are greater than 97, any values that are smaller than 4, we know that we will have strays. And you know, by quick look, just quickly looking at the data, do we have any values that are greater than 97 or smaller than 4? No, we don't. We see our lower value is 31, upper value 94. So by definition, or quite simply saying, this question's over, because we know that outliers will be greater, they'll be more extreme than strays. So we could essentially just end there, but we'll calculate them anyway for good practice. Okay, so we do the exact same thing here as we did here, except we're using a multiple of 6, not 3. So again, we're starting with the median, 76 plus, open bracket, this time 6 times, open bracket, the upper, 83, minus the median, again 76, 1, 2. There we go, and that is our value for the upper bound fence when we want to find our outlier. So you have 118. I'll do the same, trying to find the lower bound. Again, 76 minus, open bracket, 6 times, open bracket, median 76, minus the lower, 52, closed, negative 68. So not very likely, because I don't think it's possible to get a score of that low. So there you go. That we have found the 2 fences, or the 4 fences, to find out strays and outliers. So if we had any values that were greater than 118 or less than negative 68, they would be considered outliers. And the same over here with strays with these 2 values. Okay, awesome. So that is B. Cool. Okay, not wasting any time, we're going to jump straight into C. C, using a bin range of 10, construct a frequency table and then plot a histogram of the data. Comment on the shape of the distribution. Okay, so we're going to have to create a histogram with the frequency table. What I'm going to do here very quickly is just show you how how we can do this quite easily without having to actually physically set up the frequency table. So under data, if you don't have this next to outline or forecast, you'll have the analysis tab, and if you don't have that, that's not a problem. I'll show you how to do that now. You go into file, you go into options, you go to add-ins, you go down here to Excel add-ins, you go, and you just tick the analysis tool pack and you click OK, and then it should pop up. And so what I've done here already is I've put down all our values in order. You can have a look. All these values over here I've popped in. And so now what we're going to do is I'm going to select every one of them. Oh, before we do that, we need to put in our bins. Okay, so I forgot about that. Okay, so 2 ways to do this. You could set 10 as your upper bound, but I think we'll be using 9 here. So if we put 9, we'll then have 1929. Little trick over here, if I'm going to drag down. Essentially what this means is that when we use these numbers as our bins, they'll go 0 up until 9, not including 10, and this 10 to 19. If we had 10 instead, it would be 0 to 10 or 0 to 20, but we're going to be using 9 here. Okay, awesome. So once we've got everything down, that's good. We then go to data analysis. Scroll down until you find it. I've got already selected histogram. You press OK. You choose your input range. Okay, input range. Drag all your values. Okay, awesome. Then your bin range, which we have set up over here. Okay, very happy. No labels. You can leave that as is, and you can pop a chart output. And now we go OK. And there you go. What Excel has done, it's done the frequency table for us. It's told us our bins. It's counted. So just to double check, let's check the first one. So up until 39, there are 3. So if we go into our data, 1, 2, 3. Okay, awesome. Works. And then once it's done, it's actually done the histogram for you, which is quite nice. So here we go. Now any comments, I guess, that you have on the data, you could say, you know, maybe you might want to show this, you know, where one might expect that the data were almost pyramid shaped, but here we have the low value is a bit higher, then dips down and stays almost constant towards the top. It kind of peaks. So you could say that the marks on the distribution were quite high, so quite high marks in 2016. But any kind of comment is usually accepted as long as you justify what you see or the shape of the distribution of the values. But definitely quite high, so we're very happy with that. Awesome. So that's it. What you can also do if you didn't want to use the data analysis, you could of course used the frequency command or formula. You would have then had to put your bins, and you would have had to do your whole F2 Control Shift Enter. But I find this is a lot easier. You know, it's a lot quicker. Awesome. So there we go. We've commented. We've constructed a frequency table and a histogram. Bin range of 10. Bin range of 10. Probably should have commented on that because we wanted 10. So in 0 to 10, 10 to 20 kind of thing. We did 0 to 9, 9 to 19. Still 10, but just a bit nicer here. Awesome. So now we want to construct a box and whisker plot for the data. One way to do this, we're going to go straight to our sheet 2 where we have all the data. We're just going to select all the data. We're going to go to Insert. We go to Recommended Charts or All Charts. Go to All Charts and you'll find Box and Whisker Plot. Boom. There you go. If you want to double check this, we can, because remember we've calculated the 5-number summary. We have 34 and 94. 30, looks about right. 90, yeah, okay. Happy. Where's the mean? Around 70, or the median, 70 something. Let's have a look. Yeah, there you go. Awesome. Okay. Box and whisker plot solved. Box and whisker plot. Okay, very happy. You could have also, I guess, drawn this by hand. Very possible, using the values that we calculated, but you know, if Excel can do it for us, why do any work? Okay, jumping into the next. E. Calculate the mean and standard deviation of the data from first principles, i.e. using the formula. They've given us some starting points. They've given us the sum of xi and the sum of xi squared. So very quickly I'd copy these numbers down into your Excel sheet. Or if you want to do this by hand, we've got xi and we have xi to the power of 2, the sum of those two, of course. Okay, so now very quickly, straight off formula using the mean, very straightforward. It would just be the sum of all values divided by the number. They've given us the sum of all values. We also know the number, being 25, because there are 25 values there. So to calculate the mean, it's just 1712 divided by 25, because that's what we've given. Okay, awesome. So we have 68.48. 68.48. Very happy. Okay, awesome. Now, calculating the standard deviation, it's a bit trickier. What they've given us xi, the sum of xi squared, which is a good start. The traditional formula, which you might be aware of, I think, from school time, is would be the sum of xi minus the mean, and then that all squared divided by n minus 1. But we unfortunately don't have that. They have given us xi to the power of 2, and we can make use of this because there is, of course, the shortcut formula or a simplified version of the formula if we do have this, so we can work with that. Okay, so if you haven't done already, go have a look on page 31 to 32. You'll find the formula that I'm talking about to calculate the variance using this. I've just done this now. And we have a look at the format that they've given us. I'll direct you to the top of page 32 where they state the sum of xi squared, so the sum of all the xi squareds, which we have, subtracted by the sum of xi's, so all the xi's summed, and you square that, and then you divide that by n, will be your variance. But we still need to divide that by n minus 1. So that last little step there that we still need to do. So I'm going to start out by just writing the formula out for what we use. We'll not write the formula, jump straight into actually doing it. We have the sum of xi, which is given to us, which is 126,930. Cool. Very good. We now subtract the sum of xi's squared, so 1712 squared. So we square that. I don't know if this is now stuffed. No, that should be fine. And we divide that by n, being 25. Awesome. So next step, so we have this value. If you follow me on paper, this is what you should be at. And we now need to divide this entire number by n minus 1. So n minus 1, 25 minus 1, 24. We divide this number now by 24. And that should give us our variance, 403.843333. Okay, so we have 403.843333. Okay, awesome. Now, to get to our standard deviation, we just have to square root this. So, very quickly, boom. 20.096. 20.096. Okay, very happy. Yep, just double check that. That is exactly what we should be getting. Now, what you can also do if you are using Excel, you could have also just selected all the values, or you could have used a formula to calculate the mean or standard deviation for this, and you can do that to double check. So I'm going to do that quickly. So it's equal to or average, not mean, average. Okay, so I'm going to select that of all these numbers. Select that, close brackets, enter. 68.48. Is that what we got? Yeah, perfect. We can now do is equal to standard, SDEV S, because this is a sample. Select all our values again, close bracket, 20.0959, yeah, or 6 rounded up. Perfect. So we see that these two values that we got match what we have here, which we calculated using the formulas, and so we know that works out. Okay, very good. Now, jumping to question 2, I'm sure your tutors have worked through this one. This is quite an easy one because you do not actually need to use Excel. Student achieves the following marks for her assignment. And we've got all these numbers, and you can see they are not ordered. This is 96, doesn't seem to fit in here. 60, okay. Anyway, which box and whisker plot correctly represents her performance? Okay, so we have a multiple choice question. Best way to deal with this with box and whiskers, first thing, find the min and the max, because we can see they are not equal. Okay, so we visually inspect all the numbers we have and we find, okay, 60. 60 is our smallest number. Now, A, whoops, no, that does not look like 60. B, nope, not 60. Okay, so we can cut those two out. C, D, 60, 60, very good, very happy. Checking our maximum number, 100, yeah, no bigger numbers, 100, okay, very good. Next step, I don't think there'd be any point in looking at the median because they look very similar. You could calculate this. I would implore you to actually calculate the 5-number summary for this so you can be 100% sure. But what I'm going to do is I'm actually just going to look at the box and whisker plot and try to see or figure out what kind of fit, what does the data look like? Does it look more like this or does it look more like this? And so we go back to the data. Okay, so we've got 100, we've got 3 90s, quite high 90s, not low 90s. We've got an 88, we've got an 84, we've got an 80, and we've got a 60. Okay, so the numbers seem to be quite big or quite high, quite close to 100. So looking at D, we see that there's this very big area over here determining, well, I mean, this being the lower quartile, this being the upper quartile. So if the lower quartile is meant to be that low, but the numbers are so big, I don't think that really works out. And especially if the upper quartile is also not that big or not that different. And it's even below 90, and just looking at the numbers, most of them are above 88. Or not most of them, but a large number of them are above 88. So D, I think we're going to have to cut out. And if we look at C, you've got quite a nice big upper quartile. I think that fits the data a lot better. So we go with C, and C will be your answer. You can double check that by calculating the 5-number summary for these numbers. So that concludes this week's or week's 4's questions. If you have any questions about the tutorial questions, I'd recommend going to your tutor there's anything you're struggling with, go ask them, come to the workshops, come look for us. We are very helpful. We'll help you with anything you need. And yeah, all the best.